Okay, so we just left off on this video talking about inverse variations and direct variations. Well, we left off talking about inverse variations. So now that you understand inverse variations and you know that it's very similar to the process of solving them as direct, let's go ahead and do some applied problems of these direct and inverse variations here to kind of bring these two to a close here. Let's say the circumference of a circle. So let's see, the circumference of a circle C varies directly as the radius R, and C is equal to 7 pi. Let me write that in. And it says, and C is equal to 7 times pi. Of course, this is in feet. When R, which is your radius, is equal to 3.5 feet. And the question says, find R when C is equal to 4.5 times pi feet. Okay, so let's look here for a second. Let's reread the problem here so we can get a clear understanding. The circumference of the circle C varies directly, as the radius R, and C equals 7 feet when R is equal to 3.5 feet. So this is as the radius, that looks like roads, as the radius, let me rewrite that. As the radius R and C is equal to 7 pi feet when R is equal to 3.5 feet. Okay, find R when C is equal to 4.5 feet. Alrighty, so let's go ahead and do this problem here. This is supposed to be a comma. I'm not sure what it looks like to you guys, but it seems like it's coming out wrong. We're just not going to put it. Okay, so let's go ahead and look at it. Well, it says varies directly, so that means we're going to be using the equation y is equal to k multiplied times x. But now we have to change our variables here, because it says y is equal to k times x. It says the circumference of a circle varies directly as the radius. Now remember, this here says, it says what? It says y varies directly as x. This here says the circumference of a circle, so it's basically saying C varies directly as R. So this says y varies directly as x. How do you think C varies directly as R will look? Well, it looked like this. It looked like C varies directly as R. So C is equal to K times R. We're finding because we want to find the relationship between C and R, the circumference and the radius. Well, let's go ahead and find it. We know that when the circumference is equal to 7 pi, our radius is equal to 3.5 feet. Okay, so let's go ahead and solve for k in this here equation. Well, let's do that by dividing both sides by 3.5. Then those will cancel and leave me with k is equal to 7 pi divided by 3.5, which will be k is equal to 2 pi. Okay. Now that we have this, we already know that our equation, our variation function here is going to be what? C is equal to, all you have to do is substitute what we've found for k and for k here, which will be C is equal to 2 pi times R. Well, what is this? This is the area of the circumference of a circle formula, which is not surprising. We already know that because we already knew the relationship between the circumference and the radius was c is equal to 2 times pi times r. We already knew that relationship exists. We just basically proved this relationship by using our direct variation and by finding the constant of variation. Well, let's see something here. Let's actually answer the question. It says find r when c is equal to 4.5 pi. Well, now that we found the rule or the constant of variation here, we can actually go ahead and find anything. So it says when c is equal to 4.5 pi, what is r? So 4.5 pi is equal to 2 pi times r. Well, let's solve for r. We got to divide both sides by 2 pi. And when we do that, we'll get these to cancel, and it'll be 4.5 divided by 4.5 pi divided by 2 pi. These cancel out, and 2 divided into 4.5 will give me 2.25, which is equal to the radius. Okay, so this says when my circumference is equal to 4.5 pi, my radius is equal to 2.25. So the radius is equal to 2.25. Okay, and that is the answer to this here problem, to this here applied problem. Okay, let me go ahead and show you another way that we can do this here problem, which is actually by using proportions, because this is indeed a proportion. So I'm going to show you that in just a minute here. Let me erase this. Okay, let's look here. It says the circumference c varies directly as the radius r, okay? And c is equal to 7 pi when r is equal to 3.5 feet, okay? Find r when c is equal to 4.5. So if we set up a proportion, we can set it up equal to, we'll call this circumference 1. So we'll set this up equal to, let's see here, circumference 1, which will be the circumference when 7 pi is equal to, the circumference 1 will be 7 pi. And it says this is to 3.5. So when the circumference, I'm sorry, I didn't mean to write the numbers in there yet. I'm just trying to give you guys the formula here. So C1 over R1 should be equal to, proportional to C2 over R2, right? Because we're going to have the same constant of variation here. So let's go ahead and see. What is C1? Well, C1 should be 7 pi. So 7 pi divided by R1, which is 3.5, because the value of the circumference when the radius is 3.5 is 7 pi, which is proportional to the ratio. Well, it says find r, so that means we're going to have, let's say we'll have r in the denominator, and the C2 would be 4.5 pi. Okay, so this is a proportion that we can solve for r. If we do our cross product multiplication here, we get what? We get 7 pi r is equal to 4.5 times 4.5 pi times 3.5 pi, and we'll get 15.75 pi. Now we want to solve for r in here, so let's divide both sides by 7 pi. These 7 pi's cancel, leaving me with r is equal to 15.75 pi divided by 7 pi. Well, these pi's cancel, and 15.75 divided by 7 is equal to 2.25. And this r is equal to the same r that I had in my last answer here, okay? Now let's go ahead and take a look at, let's see here. Yeah, let's go ahead and do an inverse variation applied problem. Let's go ahead and do that. Okay, so let's go ahead and erase this so we can get a inverse variation problem. Now, let's look here. I want to introduce you to something. Before we do that, I want to just draw something to your attention. If we say y1 is E is inverse proportionally to x1, right? We imply that this is what? Well, we can say that this, if we want to, let's solve for k. What is k equal to? We imply that k is equal to y1 times x1. Because if we multiply both sides by x1, those will cancel and be left with k is equal to y1 times x1. Okay, so that's equal to k. Now, let's look here and let's watch this. If we say y2 is inversely proportional with x2, it varies inversely with x2. I didn't mean to say inversely proportional. It varies inversely with x2. What does this say? What is the value of k? We imply, let me write that in a different color. We imply here that k is actually equal to y2 times x2, which will be equal to k. Okay, well, we have y1 times x1 is equal to k, and y2 times x2 is equal to k. Therefore, we can go ahead and say this. So we can say, so based on the transitive property, which transitive property states if A is equal to B and B is equal to C, then C is equal to A, right? Because if A and B are the same number, let's say A is equal to B, so that's going to be 4 is equal to 4. Then B is equal to C, so that means that must be 4. So that we must say that these two are equal, which they are. That's the transitive property there. So if y1 times x1 is equal to k, and y2 times x2 is equal to k, we can imply and say that y1 times x1 is equal to y2 times x2. Okay, which this is indeed a true statement, and this will come up when we're dealing with inverse proportional variation. Inverse variation. I don't know why I keep saying proportional, but inverse variation. Okay. So let's go ahead and get to the problem here. It says, let's see, it says the time, let me write that up because this is kind of a long problem here. So give me a second to write this here. To construct a house, it varies inversely. It varies inversely as the number of volunteers. Which we'll call V. Okay. The question here says, let me write the question in different colors so you'll know how to differentiate between the question and actually the given information. Okay, it says if 20 volunteers can build if 20 volunteers can build a house in 62.5 working hours, how many volunteers would be needed to build a house This is a long question here. A house, it's just a lot of words. A house in 50 working hours. Okay, in 50 working hours. Okay, perfect. So now that we got this question here written down, let's go ahead and solve it here. It says, the time that it takes for a group of volunteers to construct a house varies inversely as the number of volunteers V. So that means there's a relationship between how long it takes them to build the house to how many volunteers there are. If 20 volunteers can build a house in 62.5 working hours, how many volunteers would be needed to build a house in 50 working hours? Well, if we take a look at this pink part here, we see that it says the time that it takes for a group of volunteers to construct a house varies inversely. See, it's varying inversely. So that's going to be the key thing to tell us we're dealing with y is equal to k divided by x. Now, it says t, this basically says t varies inversely with v. So the time varies inversely with t. Remember how inverse variation said y varies inversely as x. So y varies inversely as x. This says t varies inversely as v. So if y varies inversely as x, looks like this. How does t vary inversely with v look? Well, t is equal to k over v. Okay, that's how that will look. Let me rewrite this right here. So let's go ahead and do it. That says t is equal to k over v. So we want to find what our k value is. Well, it's given that if 20 volunteers can build a house in 62.5 minutes, working hours, so 62.5 is equal to k, because we're going to find k, over the volunteers, number of volunteers, which is 20. And if we solve for k in this here equation, we multiply both sides by 20. Those cancel. This will be multiplied times 20. We'll get k is equal to 1250. So 1,250. Okay? Perfect. Now that I have this, let's go ahead and use this to find our answer our question. Okay, so it says if 20 volunteers can build a house in this many hours, how many volunteers will be needed to build a house in 50 working hours? So our equation says t is equal to 1250, because we substitute that in for k, over v. So how long does he want the house to take to build? 50 working hours. So this would be equal to 50, which is equal to 1250 divided by v. Now, if we actually solve for 1250, we solve for v in here, we'll get, this will be 50v, which is equal to 1250. And then once we divide both sides by 50, we'll have v is equal to 1250 divided by 50, which will be 25. So that's a 1250, which will v is equal to 25. So what this says here is that we need 25 volunteers in order to build a house in 50 working hours. Okay? Go ahead and take a second to write that down. Pause the video, because I'm actually going to show you, this is called method 1. In a minute, next I'm going to show you method 2 of solving this here. Okay? Well, if we remember when we talked about the transitive property and how y1 times x1 is equal to y2 times x2, well, that's the same thing we can use here. It says here that if we use, it says that the time 1 times the volunteers 1, which would be your 6.25 and your 20, is equal to your time 2 times volunteers 2. Okay? Well, let's go ahead and see what this will be here. 1 second here. All right. So let's see, time 1 we said is 62.5 times the volunteers, which is 20, is equal to time 2. What do we say time 2 was? We want it in 50 hours times V2. Okay, so we're going to find what V2 is equal to, right? All right, so let's go ahead and simplify this here. We'll get 62.5 times 20, which will be 1,250. And then that is equal to 50 V sub 2. And we're dividing both sides by 50 in order to solve for V sub 2. So we get V sub 2. We get V sub 2 is equal to 1250 divided by 50, which would be 25. Okay? So that tells you that the value, that tells you the same answer that we had last time, that in order to complete the house in 50 working hours, we must have 25 volunteers. Okay?